The last thing we went over this week was how to analyze z-scores when we are dealing with population proportions and sample proportions. When we know a percent of people believe this, a percent of this many phones is defective, when we're dealing with percents and portions of a population instead, and our formulas are going to be a little bit different, but the ideas will be very, very similar to up top. So we need to start labeling it up, and I'll start narrating through how we're going to think about this differently. So we believe that only 25% of survey respondents complete a full questionnaire. If we take a sample of 116 respondents, what is the probability that fewer than 20% actually completed it? So we believe that when we send out a survey, only 25% of people are actually going to take that survey. Okay? So that's that's what we believe is true of the population. P is equal to 25% or 0.25. Oops, let me make sure that decimal is obvious, 0.25. That is what we believe is true of the population, that only 25% of people are actually going to complete a full questionnaire. But if we take a sample of 160, we want to know what is the chance that 20% or fewer of our sample are actually going to take the survey. And what we call that sample, what the possible sample proportion is p hat, with that little symbol up top, which is going to be 20% or 0.20. Okay? So we want to know if we believe only 25% of the population is going to fill it out, but if we take a sample, what is the chance that the sample actually has 20% fill it out or less? Okay? One of the biggest changes is how we get the standard deviation. The standard deviation wasn't given to you in the problem. To get the standard deviation that we need, we are going to take the population proportion times 1 minus the population proportion divided by the sample size, and all of that's going to be underneath the square root, and that's what we're going to need to use for our z-score analysis. So down here I'm going to, in red, I'll find our standard deviation that we're going to use. So I'm going to take the population proportion, not your sample proportion, the population, 0.25 times 1 minus 0.25 divided by the sample size of 160, and that's all underneath the square root. So now I'm going to put that square root, parentheses, the population proportion times 1 minus the population proportion divided by our sample size. And we are going to use, and I'm going to use 4 decimal places, we're going to use 0.0342 as our standard deviation for this problem. Okay? So now we are able to go find a z-score. And with a z-score of population proportions, we are going to take p hat, your sample proportion, minus the population proportion that we think is true of everyone, and we're going to divide that by the standard deviation. So we take p hat minus p, and we divide it by the standard deviation that we just got. Very similar to how we found z-scores up top. So 0.2 minus 0.25 divided by our new standard deviation, which we had to calculate by hand, and we will get a z-score of negative 1.46, and that will round up to 20. Okay? And now we need to go take that z-score and take it to our spreadsheet to know the probability. As we can see, this is a left tail problem, so I only need to go grab the left tail from my spreadsheet. So I'm going to go take negative 1.462, replace that up here, negative 1.462, and I'm going to change my formula. I'm actually just going to click this time, and I see a left tail of 0.072. 0.072. So there's a 7.2% chance that if we took a random sample of 160, 20% or below would actually fill out the survey.